Hey Chatur.
Yes, Surya.
Okay.
Yes, Surya.
What are the things we'll be covering in next 1 hour?
Next one, I will probably give them an introduction to some of the object-oriented programming concepts, some
Okay.
good practices,
The OOP
and
concepts,
yep,
right? Okay. Okay.
just the introduction to the concepts, just
Okay.
so you know everyone isn't overloaded.
Yeah. Cool. So yeah, you can continue that even on tomorrow as well. Okay. Cool. Great.
Yep. All right. So is everyone back? Uh, if everyone's back, we can probably start with the next half. All right. So I suppose everyone is back. So let's get to the next half. Before that, I just give a quick recap as to what we have covered till now. So initially we understood what a class declaration is, what the attributes of a class are, and what a method is, and how it helps you to set a functionality or perform an operation on the attribute. Okay. So our next agenda would be, to understand the object-oriented programming concepts. Okay, so on a high level, let's OOPS concepts revolve around majorly encapsulation and inheritance and polymorphism. Okay, so what we are going to cover today is encapsulation and inheritance. Before that, let's understand what is the need for this and what exactly are OOPS concepts. So you all must have heard about C++ languages, right? So these are nothing but procedural languages. Hello, am I audible?
Yes, Chatur, you're audible.
Okay, okay. Okay. So the three main concepts are encapsulation, inheritance, and polymorphism. So say let's pick up the first part, the encapsulation. With refers to this class, suppose you are a developer and you write a code for your class, which is going to be used by a dozen other programmers who are working under you. So now look at the problem. Now imagine that after later on when they're using it, uh, you decide that the way you have written the class is not good, and you decide to change it. So once you change it, what is going to happen is the other programmers who used your code to write their own code, their code is going to break. Their code is going to break. So, oops, yeah. So their code is going to break. So in that case, what you essentially have to do is design your class in such a manner wherein no matter what change you do to your class, the programmers that are using your class should not be affected by it. Okay. So let me give you like an example. So in short, your class should be flexible and maintainable. Now I'll give you an example which is a bad practice so that you understand what to avoid. So say for example you have an integer I, and you have another let's take meaningful for this case. Let's say you have integer size and then integer weight. Okay. Now what I'm going to do is I have another class, say public class use bad practice. So I'm just going to create a main method here, just like the previous examples. And I'm going to so for the Eclipse convention, let's use this inside another class file. And then you have a main method here, just like before. And then, uh, just like we created an object in demo class, we will go ahead and create an object of bad practice class. Say you write bad practice, say v1 equal to new bad practice. Now, what you are able to do is when you do b dot v1 dot, you have access to the size and weight. Now consider you're assigning a value 10 to it, and I'm just one of the programmers who is using this class created by you called bad practice. And now say there are two other programmers, say there is Suren and there is someone else. So they too are using this class. But unfortunately, what they're able to do is edit the values of the class directly. So say tomorrow, the value of this variable, the name, I'll change it to say size to height. What this essentially will do is you have utilized this code in your class, but it broke it because I changed the way my class was implemented. Okay, so there should be some way wherein no matter what I change here, it shouldn't affect my class that is using it. So this is the concept of encapsulation. You are going to hide the essential complex details from the user who is going to use the class. So no matter how you implement it, no matter you change the logic inside your class, the person who's going to use your class should be totally unaffected by this. This is nothing else but encapsulation. So let's how can we solve this? So one good way to do this would be making this private. We'll come to access specifier in a moment, but for now do understand that private is this will allow you to use this variable only inside the same class. The variables, the objects outside this class will not be able to use these variables. And then you provide a method. We call it getter setter methods. So let's take this example. So you have a method that returns the height. So now, thinking from a perspective of a programmer who's going to utilize your class, he won't have access directly to the variables like he had a couple of minutes before, right? So now, all he's going to have access is to get height. So I'll be declaring an int height value that will receive the value inside this. So say for now I'm giving it a value 10 and I'm going to print it out here. Okay, let's quickly give this a run. There you go, height is 10. So I'll just quickly reiterate what I was saying. So you are providing a mechanism in bad practice wherein you only return the value and you don't allow the users of your class to edit it. So by this method, you can do any change inside your actual code without them requiring to actually change their code. Say for example, I change the value of this variable to size and I say return size. This is my class. But the user that is using this is still unaware that the variable name has changed inside the class that was created. He is going to be oblivious of it and is just going to give it another run. He's still going to get the same output. So from a user perspective, I'm totally unaware as to what the source class changes had been made. So this is encapsulation wherein you hide the essential complex details from the user who is going to use your class in order to safeguard it from unnecessary editing and modification. So what y'all can do is give this a quick try and let me know once you're done. Create two classes, create a getter method for it, assign a value to the variable you're declaring, and in another class, create an object of that previous class and access the value using the getter method. So for reference, if you want me to switch back and forth between any of these classes, do let me know. Yes, yes. Yep, sure, I can repeat it. So the concept is encapsulation. So the idea behind encapsulation is to hide the details and complex implementation of your class from the user. So first, let's take the programmer perspective. Suppose I'm creating a class, you know, that has some attributes and values to it, and I want to give that access to the subsequent programmers who work under me. So they will be my users. So now, if I directly allow them to access this int size and int weight, they'll be free to modify it directly. So from a perspective of a team, wherein there are 10 different programmers who are going to use my class, all of them will edit this value as per their requirement, which is not what we want. And secondly, if tomorrow I go ahead and change this name of the variable to something else, then their code will also break because they have used these variables directly. So how do we ensure that no matter what I change inside my class isn't affected to the subsequent programmers who utilize my class? Okay. So one good way of doing it is by providing a getter method. So a getter method is nothing but it will return the value held by the variable, wherein they will just be able to read the value and not edit it. So by this way, no matter what implementation logic you're changing at your end from a programmer perspective, the users will be oblivious and unaffected by it.
Chatur, in bad practice class, that get height call,
Mhm.
what exactly it is doing?
Mhm. It will just return the value of the size variable. So I had initially named it as height, but I wanted to show you that no matter I change, whatever change I do it here, the user of this class is unaffected. So this was the initial code. So the height value is 10. The get height will return an integer value, and all I'm doing is using a return statement that will return the value of height. In short, it will return the value 10 back to whomsoever calls this method. So in our case, the use bad practice class is using that. So I have created an object, say bad practice b1, and I'm just using the get height method that returns the integer value 10 and stores it in this, and then I'm printing it.
Okay.
Yeah. Please do let me know once you have done, once you have completed trying this, then we can move ahead. Okay, I'll just wait for a few minutes more, then go ahead.
Hi Chatur.
Yeah, hi.
Can we use two return statements? Means can we return means multiple return statements in one function in one method?
No, you can't.
Okay.
So the
Means per
so
method.
the essence of, yep.
Okay. So that means per method it's one only return statement.
Exactly. So the essence
Okay.
of return is a method should process and come to a single conclusion, right? So then it's returned back. So that's how OOPS works.
Okay. Okay. Got it. Thank you.
Yeah. Okay. So I'll move ahead with this. Um, all right. So the next part would be, what if you want to set a new value to the variable height? Okay. So as most of you must have probably guessed it. So while we were using get height as a way to retrieve the value, we can use a set height. The names of the methods are totally your choice. I'm giving it for the understanding that it will be easy for you to uh, link it. So set height. So what I can do is I can do height equal to height plus 10. So now from a programmer who uses this class, first I can do int new height value equal to p1 dot set height. Yeah, since this doesn't return any value, we don't need to specify the left hand parameter for it. So okay, so uh, yeah, now what will happen is, let me just run this. The new height value is 20 because what I did was I added a value of 10 to the height, and the new height value got printed. So in scenarios wherein you want to assign a new value to the variable, you can use a setter method. Hence these two methods are like the key for encapsulation if you want to get started with it. We call it getters and setters. In technical terms, they're also called as accessors and mutators. But for now, let's stick with getters and setters. So now this, as you must have observed, and some of you might have questioned this also, thinking, what if I want to send a custom value to this? So just adding 10 to this won't suffice, right? So that's where a method parameter comes into picture. You just pass a parameter saying any name called height value, and you can just add it with the height value. Now when you're setting this height here, you can directly pass whatever value you want to add to the initial height value. Say I want to add 50. Then I give it a value. So this basically also gives you this fulfills two basic requirements of a programmer. One is to read a value, another is to write a value. So you can safely read and write a value without your code getting affected if bad practice class changes. So this is in a nutshell an entire concept of encapsulation. So I just want you all to go ahead and try setting a value and get an output out of it. I'll wait for 2-3 minutes. Once that is done, I'll go ahead with the next topic. Yep. Please let me know if you are done. Okay, so I'll wait for 2 more minutes and then move ahead. Okay, so I'll move ahead with the next part. Okay. So I'll go ahead with the second part, that is inheritance. So as the name itself suggests, it is basically how one class inherits attributes or properties from its parent class. Now let me give you a real life example. So let's imagine a class called vehicle. So in a day-to-day life, when we say vehicle, a vehicle is nothing but it has an engine, it has four wheels, it has a steering and other properties, right? So, and then imagine a class called car. So a car too has the same properties that vehicle has. So basically, car has inherited the properties and attributes of the class vehicle. All right. So I hope this is clear. So this is nothing else but inheritance. So the idea behind OOPS concepts is to model real life, because procedural languages don't successfully do that. So one of the key pillars, or I would say a backbone of OOPS, is inheritance. So it is very essential for us to understand this. So I repeat my example again. So there is a class called vehicle. It has some properties called, you know, uh, four wheels, and it has an engine. And then there is a class car. It inherits the properties of class vehicle, and thereby has four wheels. It has an engine. It has a steering. And let's go a step further. You know, say I have a Maruti Swift. So once I have a Maruti Suzuki Swift, the Swift is also a type of a car. So Swift inherits the properties of a car and thereby inherits the properties of vehicle itself. Okay, so this is how inheritance works. So another good example would be an animal class. So an animal has movement, can see, can sense, can taste. So a horse class would actually be a derivative of class animal. So it inherits the properties of class animal. Okay, is this clear? Please let me know if this idea was understood. Hello. Please, you can ping probably if you have understood. Else, I can explain it again. Please let me know. Okay, sure. So let's say that there is a class vehicle. Okay. So a vehicle has some properties like it has four wheels, it has an engine, it has a steering, it has a way of moving forward, backward, right? So now, now out of this, imagine a totally different class called a class car. So coming to think of it, you'll realize that the car basically does the same thing a vehicle does, but in a more specified way, right? So a car moves forward, backward. It has a steering. It has four wheels. It has an engine. So basically, car has derived some properties or most of them from a class vehicle, right? So it has inherited it. So if you move a bit further, if you become more specific and say a Suzuki Swift, right? A Suzuki Swift 2 has an engine, steering, brake, wheels and moves forward, right? So it has inherited the properties of the class car, which in turn has inherited the properties of class vehicle. So what this establishes is a inheritance relationship. So another example would be, animal. An animal can be any animal, right? But all animals have a way of moving forward. All animals have a way of sensing things. But when you go a bit more specific, say a class horse or say a class tiger. So a tiger has a specific way of moving, right? But yes, it does move, right? So it has inherited the properties of class animal. Okay. So this is an inheritance relationship that is being described here. Is this clear, Deepak? Okay, great. Right. So I'm going to take an example and let's see how we can implement this, using Java. One simple way of understanding would be via mathematical operations that will quickly make you understand how this happens. So say I have a class called mathematical operations and I have a variable, say A. Now I have a method that performs addition, okay, that performs addition it takes in two parameters, say int x and int y. Or for our better understanding, I'll say int number 1, number 2. Now, all I'm going to do is store the result of the addition of two numbers into the variable A, saying number 1 plus number 2. Okay. Now, I just print it out here itself. Result of addition. As you must have probably guessed, I'll be writing another method called subtraction, wherein I'll be taking similar parameters and then I'll be storing the result of the subtraction values inside the A variable. So for better understanding, I'll just rename this variable as result. Now, this is one class I have called mathematical operations. Now I'm going to create another class saying multiplication. Okay. Now, or rather, let me rename this as calculator. Now, what we want to understand is how can calculate inherit properties of mathematical operations. So in Java, we have a keyword called extends. So what this basically does is establish a relationship of inheritance, like I described before, between calculate and mathematical operations. Yeah. So now, when you're going to read this, you will read it as calculate extends mathematical operations, wherein mathematical operations class is the parent class and calculate class is the child class or subclass. So any class that inherits properties from the class above it is called as a child class. and any class that is acting as a parent and provides its properties to its subclass is called as superclass or a parent class. I'll mention it here for understanding. And so the moment we extend the mathematical operation class, just like I described in the example of vehicle and car, the attributes or the properties of mathematical operations will automatically come down to the calculate class. So what does this mean? First, let me write a method. So public one multiply, and let's say int okay. So did you all notice that I'm freely able to use the result variable? As you must have also noticed, I haven't declared this result variable anywhere in the calculate class, but I had declared it in the mathematical operation class. In line with what I was saying, that the properties come down to the subclass, the results property came down to the calculate class, and I was able to use it directly here. Okay, so that is one example of properties getting inherited. So I'll just quickly print this. And we have it. Now, as previously said, main method is responsible for execution, right? So I'll be declaring a main method, and say I have a variable called int number 1 and number 2, and I have given them some initial values saying 10 and number 2 as 20. Okay. So now number 1 holds the value 10 and number 2 holds the value 20. Now, in order for us to access the calculate class, we need to create an object, just like we did in the demo class. Okay. So what we'll do is we'll write calculate, say C1 equal to new keyword calculate. Now is the key point. Please pay attention to this. So once I do C1 dot, I have access to the result variable, to the addition method, and to the subtraction method, along with the multiplication method which I had written here. So you must have observed that the subtraction, addition, and the result, these methods and properties automatically came down to the calculate class. So even though I don't have the addition method defined here, I can use the calculate methods object to call the function or the method of its parent class. Okay, in this case addition. And what I will do is I just pass number 1 here, number 2 here. Okay, so the moment I give this a run, it should give me an addition of 30. There you go. So this entire method of addition was located inside a mathematical operations class, which was inherited by the calculate class and accessed by the object of the calculate class itself. Now, next would be C1 dot subtraction. Let me pass number 2 here and number 1 here. C1 multiply. give this a total run, and as you can see, this addition and subtraction which are present in the super class or the parent class got invoked, and they gave their respective results, and the multiply method which is present in the calculate itself was also invoked, and it gave the result. So this is a very simple example of how inheritance works and how you can, send down properties of your class down to the subclasses. Now, what is the main use of inheritance here? Okay, so there are two main uses of inheritance. So one is to promote the reuse of code, and the second is to provide polymorphism. So polymorphism is something we'll get into detail probably in the next session. But yeah, we have addressed the first property of inheritance, that is to promote code reuse. So in a bad practice scenario, wherein you have two different classes, say there is one class that performs addition and subtraction, and you also want to perform addition subtraction in another class, you will end up writing this same method again, which is redundant code. We want to avoid that. So we use the inheritance mechanism to actually, pull down the methods and reuse it. Please try this at your hand right now and let me know how it goes. And also let me know if you want me to switch back and forth between the parent class and the calculate class.
Hey, Chatur, Suren here.
Yeah, hi Sunil. Yeah.
Chatur, so like I think we can you can try to wind up today's session and then continue tomorrow. It's already 12.
Sure.
Yeah.
Okay then.
Yeah. After this exercise, of course.
Yeah, sure. No problem. Yep. Please try this at your hand and let me know. Then, like, we are done for the day. Uh, if we can wait for 5-6 more minutes, and then we can wind up. Great. Suren, should we wind up then?
Yeah, sure. Okay.
Okay.
So guys, how was it? Like you guys enjoyed? You was able to learn more? Don't worry, guys. I think Rahul and others, don't worry. I'll probably what I would ask is, Roshan, like what I would ask is, I would ask Chatur to basically check in these particular code in the GitHub and ask you, yeah, and ask you to send it through the, yeah, I'll ask you to send it through the WhatsApp, okay? So that you guys can actually go and download that the same way we did for Selenium. Does it make sense? Cool.
Great, guys. I hope you all enjoyed the session. And if you all have any queries, do shoot me a ping. I'll be added to the Slack channel also. All right. That's it from my side then.
Okay. So shall I ask a question for you guys and then wind up? Great, great. Just kidding. Good to know that you guys are interested and good to see your participation. Thanks, Chatur, for a wonderful session. We will share the recording as well. So yeah, thanks again. Thanks everyone. Catch you
Yep.
up.
Thank you,
Catch
everyone.
you up tomorrow. See you.
Bye-bye.
Suren, regarding Maven link.
I had already shared it to you, Rahul.
Okay, I have not seen that.
You see your chat. You would be able to see it in chat.
Okay.
Yeah.
Yep. Thank you.
Thank you, guys. See you.